In this video, we will share basic and important angle theorems that you must be familiar with. Two angles are said to be complementary when they add up to 90 degrees. That is, if I have an angle here, let's say this is x, I have another angle here, this is what? Y. For x and y to be complementary angles, x plus y must equals 90 degrees. Two angles are also said to be supplementary when they sum up to 180. If this is x and this is theta, or this is y, y plus x must equals 180 degrees. That is, if I have an example, I am told that probably this angle here is 50 degrees, and I'm asked to find angle theta. Finding angle theta should be easy because 50 plus theta should equals 180 degrees, supplementary angles. Then theta will equals 180 minus 50, which is the same thing as 30 degrees. Let's see the next. Next is the sum of angle in a triangle. Now the sum of angles in a triangle is equals to 180 degrees. That is, A plus B plus C must be equals to 180 degrees. So if I have a triangle this way, and I know that this angle here probably is 40, this angle here probably is 70 degrees, then let's label it. If this is A, B, and C. For this triangle, I've known that 40 plus 70 plus my angle at C is equals to 180 degrees. So that this is 110 plus C. My angle at C is equals to 180 degrees. C, the angle at C, will be the same thing as 180 minus 110, which is equals to 70 degrees. Let's see the next theorem. Next is the sum of exterior angle of a polygon. Now, I'm to find the sum of exterior angle of this polygon given the interior angles. Assuming I know x, I know y, I know z. Now, what is the sum of exterior angles? Now, let's see it this way. On each point, at this point here, what I have here will be 180 minus x. What I'll have here will be 180 minus z. And finally, what I'll have here also will be 180 minus y. So that the sum of the exterior angles, my sum of exterior angles will be the same thing as 180 minus x plus 180 minus y plus 180 minus z. That is equals to 180 plus 180 plus 180 minus x minus y minus z. That's the same thing as 540. This is 180 times 3. That's 540 minus x. You can now use a bracket plus y plus z. Remember, we agreed initially that x plus y plus z is the sum of angle in a triangle and is equals to 180. The sum of angle in a triangle. So that the sum of exterior angle now will be 540 minus 180. 540 minus 180 is the same thing as 360. So that the sum of exterior angle of any polygon is given as 360 degrees. Now let's see the next theorem. The next theorem is the exterior angle of a triangle is equal to the sum of the other interior angles. Here we're bothered about the angle at D. Now look at it. Remember that D plus B is equals to 180 degrees. So that if D plus B is equals to 180 degrees, they're actually supplementary angles and their angle on a straight line. B will be the same thing as 180 minus D. Also, A plus B plus C is equals to 180 degrees. So that B now will be the same thing as 180 minus B minus A, minus C. Invariably, if I say this is equation 1, I say this is equation 2. Invariably, 180 minus D is equals to 180 minus A minus C. Obviously, 180 moves to the other side and subtract itself becomes 0. I'm left with minus D now equals minus A minus C. So that D invariably is equals to A plus C. So that we say that the exterior angle, one of this exterior angle is equals to the sum of the two other interior angles. Next theorem talks about the sum of interior angle in a polygon. In finding the sum of interior angle in a polygon, I'll leave you with this formula that says that the sum of interior angles of a polygon is equals to n minus 2 times 180. Now, if I have this polygon here has 5 sides, this is 1, 2, 3, 4, and 5. So the sum of interior angle of this polygon with 5 sides will be the same thing as 5 minus 2 times 180, which is equals to 3 times 180. That's equals to 540. If the polygon has 6 sides, then we'll be talking of 6 minus 2 times 180. Now let's see the last theorem. Our last theorem will be talking about the alternating angles and corresponding angles. Now, the alternating angles is also called the Z theorem. Now, for the alternating angles, let's pick the alternating angle. Here, I have a Z shape this way. Now, obviously, if you look at this, you see that my 4 here and my B forms my alternating angles. So, my B now will be equals to 4. If you look at it in the reverse, here I have my 3 and my A forms another set of alternating angles, so that my 3 now will be equals to A. Now, but the same thing, we can now take the same shape to understand corresponding angles. Corresponding angles are angles that are in the same position when you have a line intersecting two parallel lines. In this case, I have my 1 in the same and a similar position to A. So obviously, 1 equals to A. And remember that A also is equals to 3. Here I have 3 this way. Now, if you look at A and A, they are both vertically opposite lines and they are also equal, confirming a corresponding and alternating angles. The same thing will happen to 2 and B, and likewise 4 and D. So that 2 equals to 4 will be equals to B. With this, I hope you understand these basic theorems. I would like to see you in our next class. Thank you for staying with us and see you in our next class.